is really great to be with you for this research exchange. My name is Jessica Newman, and I am a research fellow at CLTC, as well as the program lead for our AI security initiative. My talk today is about some research that was recently published in the Brookings text stream. In this work, I sought to answer the following question: how do different stakeholders' goals for explainable AI vary, and are any of those goals being realized in practice? This question is timely because the US National Institute of Standards and Technology, or NIST, is currently developing definitions and standards for AI explainability that will help shape AI practices throughout the country. The AI Security Initiative is also engaging with NIST on its development of an AI risk management framework, and we expect that explainability techniques will play an important risk mitigation role in that work. To quickly provide some background, a lot of AI technologies are considered to be black boxes, meaning there is not sufficient understanding of how and why a model provides the outputs that it does. Explainability is supposed to help and is broadly defined as machine learning techniques that make it possible for human users to understand, trust, and manage AI. Explainability has become a core principle of responsible AI development that is referenced in hundreds of AI strategies. It also plays an important role in the realization of other core principles such as fairness and safety, because if you don't know how a model works, it is extremely difficult to mitigate biased or harmful outcomes. So we are pinning a lot of hopes on the idea of explainability. But what I wanted to know was just how much variation there is in what those hopes entail and whose aspirations are being prioritized. So I first reviewed explainability research and publications from a wide range of different stakeholders, and I did find significant variation. But I also found that 3 domains emerged that had greater consistency, including engineering, deployment, and governance. I don't have time here to delve into them, but I'll highlight some of the similarities and differences. The commonality across the domains was that explainability should provide assurance about the effectiveness and appropriateness of a system at achieving its intended task. Notable differences included that only the engineering domain treated AI systems as constantly in flux and capable of regular improvement, while the other domains expected greater consistency to inform expectations and enable adherence with policies. Only the governance domain stressed the values of human agency and safeguarding against algorithmic bias. Another important difference is that all of the domains imagine different feedback loops. In the engineering domain, it is engineers' input that's incorporated. In the deployment domain, it is users' input that is incorporated. Only in the governance domain is the impact on communities and the technology's relation to the broader world taken into consideration. These findings made it clear that just because different stakeholders are using the same word doesn't mean they are trying to achieve the same goals. So I next wanted to see whether any of these aspirations are being realized in the real world. To do this, I reviewed several studies of how organizations are using explainable AI. The largest study, which surveyed the practices of 20 organizations, found that the vast majority of explainable AI efforts are being used internally to support engineering goals and are not being used to provide greater transparency with users or other external stakeholders. The study found that explainability techniques are primarily used as sanity checks for engineers to see how their model is working and to identify inaccurate correlations. Other studies explained that organizations struggle to share explanations externally due to their needs to protect proprietary data and to provide users with seamless integration. They also showed that organizations don't have sufficient incentives to share information about the weaknesses of their models. These studies reveal that despite the diversity of people involved in the debates about AI, engineering priorities are being placed ahead of other considerations in practice, and that explainability is currently failing to meet the needs of users, external stakeholders, and impacted communities. This matters because it means that for now, users and other external stakeholders are afforded little, if any, insight into the behind-the-scenes workings of the AI systems that impact their lives and opportunities. This results in an asymmetry of knowledge about how an AI system works and the power to do anything about it. In the paper, I provide 5 recommendations aimed to reduce this asymmetry. The first is to clarify and diversify explainability objectives. Organizations should be explicit about their explainability goals. The second is to establish explainability metrics. These should take into account the specific contexts, needs, and norms in a given case. The third recommendation is to mitigate the risks involved with explainability, such as privacy risks, as they can be used to infer information about the model or training data. The fourth recommendation is to prioritize user needs. For example, by focusing on the context of an explanation, communicating uncertainty associated with model predictions, and enabling user interaction and accessibility. The fifth and final recommendation is that we should not treat explainability as though it is enough to actually enable trust in AI. Explainability will only result in trust alongside testing, evaluation, and accountability measures that not only uncover, but also mitigate exposed problems. So why does any of this matter? Well, the prevalence of bias and vulnerabilities in AI models means that trust is unwarranted without sufficient understanding of how a system works. Explainability could provide understanding about how a model behaves and where its use is appropriate. But there is a significant discrepancy between the vision of explainability as a principle that reaches across domains and works for diverse stakeholders and how it's being incorporated in practice. Without clear articulation of the objectives of explainability from different communities, AI is more likely to serve the interests of those already in power. By improving clarity about the diversity of explainability objectives, AI organizations and standards bodies can make explicit choices about what they are optimizing and why. AI developers can be held accountable for providing meaningful explanations and mitigating risks to the organization, to users, and to society at large. This is hugely important today, as women and people of color are disproportionately bearing the burdens of inaccurate AI systems. And it will only be more important in the future as AI systems are further integrated into critical infrastructure and society at large. I need to wrap up now, but please feel free to reach out to me with any questions, and thanks very much.